Thank you for that warm welcome, and thank you to both of you for inviting me to come along, and especially to John Smead, who organised the whole thing, and I had a lovely lunch with him on Tuesday to discuss things. So who am I? Why am I here? You've all heard of Lord Monckton, who's this Dr. Lambert guy who's silly enough to debate him. Well, I'm actually a computer scientist. I'm not a climate scientist. I'm as much as an amateur at climate science as Lord Monckton. But I also have a blog where I write about climate science because I think it's interesting and I think it's important. And presumably, since you all came along here, you agree with me to learn a bit more about it. And the one thing that drives everything I do on my blog is that I want to check things out for myself. So I don't want to take what the climate scientists say about it. I don't want to take their word for everything. I want to check out what they said and see if it makes sense and see if it's correct. I do have an advantage there. I'm a computer scientist, but my first degree was in mathematics, so I can sometimes follow the maths that they're doing. So let's talk about climate science. So first thing to note is that we're increasing CO2. And I'm going to have, if you can see here, went along sort of fairly flat for a while, and about 1950 or 60, CO2 has shot up and increased quite a lot. And that's because of all the fossil fuels we're burning. But the actual most important thing about this graph is over here on the right. If you can read what that says, that's of radiative forcing. And if it wasn't for that, the fact that we were putting more CO2 in the atmosphere and increasing its concentration would be just a scientific curiosity. No one would really care, wouldn't really matter. But radiative forcing is important. And I know Lord Monckton explained it to you briefly, but I'll do it again just in case so we all know what we're talking about here. We have in the Earth shortwave radiation, and that comes in from the sun, and we have long-wave radiation that goes out from the Earth. If those two things are equal, if the energies are equal, then the Earth will stay the same temperature. But if you have more energy coming in than going out, then you're going to tend to warm the planet, and that difference, it's the difference between incoming and outgoing, is called radiative forcing. And I've said more coming in than going out, but it can work the other way. You can have more going out than coming in, and that would be a negative forcing, and that would tend to cool the planet. But the really interesting question, and the important question, and this is where I agree 100% with Lord Monckton, the most important question about the science, and as you can see, he's agreed with me here, and is the climate sensitivity. And what does that mean? It tells us how much warming do you get from a certain amount of radiating forcing in the long run. There's an important qualification there. What happens if you have a forcing, the planet starts to warm up, but it takes a long time. We have these oceans which take a long time to heat up. So to actually get the full amount of warming from a forcing, if it just stays constant, it might take 100 or 200 years. You get a fair bit straight away, but then a lot of it takes a bunch of time to happen. But here's the equation, very simple equation that says the change in temperature, to work that out, if you know the forcing, you just have to multiply it by the climate sensitivity. What does that mean? That means if the climate sensitivity is low, as Lord Monckton suggests over there, then we can put lots of CO2 in the atmosphere and things won't warm up very much. So if it's low, there is no problem. And this is where I think we're in complete agreement. If, on the other hand, it's high, and he has the number for the IPCC up there, if it's high, then we do have a problem. Increasing CO2 in the atmosphere will cause quite a bit of warming, and that's going to have all kinds of bad consequences. So if sensitivity is low, no problem. Sensitivity is high, yes, there's a problem. That's the key question in this debate. If you think it's low, then Lord Monckton wins. If we conclude that it's high, then I win the debate. So this is what it's all about. So here's the slide that Lord Monckton showed earlier. And I want to go through his argument so we can all see how he got there, and I want to show you where I think he went wrong. So this was the graph that he showed us from Pinker et al. 2005. it said that showed cloud forcing going up by 3 watts per square metre in 17 years. And he skipped over the calculation, but let me do it for you, because I really think we need to follow and understand how this works. It's actually really quite simple. That same equation we showed before that showed that to work out the change in temperature for a given forcing, you just multiply by the sensitivity, you can rearrange it, solve for sensitivity, lambda. So you get, to work out the sensitivity, you just got to take the change in temperature and divide by that change in forcing. And that's what he did to come up with it. Oh, he's put it up for us. Excellent. Thank you. So here's the calculation in detail. You take the 0.45 increase in temperature and you divide by the total forcing, and I've sort of labelled them so you can see what's going on. You add up all the forcings, divide them by the temperature, and the answer you get is 0.12 for lambda. And then his next slide, which I've also got here, but you can put it up too if you want, is you then take that number, that lambda that he's worked out, 0.12, and multiply that by the 3.71. What's 3.71? That's the forcing you get if you double CO2 in the atmosphere, okay? And that's why he gets the fact his calculation has 0.43 degrees of warming, and the IPCC thinks it's going to be more like 3. So this is it. This is it. This is what the whole debate is about. So since this calculation is so simple, there's an obvious question that I ask myself, and hopefully you're asking, or asking yourselves, why haven't the climate scientists noticed this? I mean, does Lord Monckton think they're fools? Well,
the only conclusion you've come to is that they were deliberately avoiding the very clear implications of Dr. Pinker's paper. They knew perfectly well that if they took proper account of that paper, they would have to evaluate climate sensitivity as low by the remarkably simple calculation that I showed you on the screen, or something very, very close to it, and they simply funked it because they knew that if they did that and admitted that all their previous reports were wrong, they'd be out of business before you would say Jack Robinson.
No, so he doesn't think they're fools, he thinks they're frauds. They're all doing it just for the money, which is a pretty extraordinary claim because, well, there's lots of scientists. Are they all in on it? And then I had another thought. What about Dr. Pinker? Why hasn't Dr. Pinker spoken up and said, you have